All right, so we're looking at issuing a contractual liability, and this is we're issuing a long-term piece of debt, a bond, whatever you want to call it, with a face amount, stated interest rate, payment date, semi-annual, fixed rate of interest, interest-only payments, with a 10-year maturity date, right? And we also went through and decided what are the risk factors that we want, and putting a price on those risk factors, assuming that this is equivalent to a 10-year treasury. And then these are the risk factors on top of the risk-free rate. And we came up with 7.9%. So then how much money, how much cash should I expect to receive if I set my stated rate at, say, 7%? Well, if I set my rate at 7% and everybody wants 7.9%, am I going to get less, more, the same? Don't know. So let's kind of look at this and let's see if we can come up with a way of evaluating or trying to figure out, modeling how much cash we might get. So here we've got a Excel spreadsheet, and we're going to just use this, and we're going to create a little template on maybe how to calculate the present value, or how much cash I should get given a 7.9% market rate, or what the investing public wants. All right. So let's say we're going to do, it doesn't really matter what the amount is, but we're going to say the face amount. Let's make sure we get all of our variables that we talked about. A face amount, the stated interest rate. We want the payment dates, and we want those to be maybe, well, we'll figure that payment dates. We want this to be interest only. Interest only payments. And we want the maturity date. Okay, so let's assume that we are planning on issuing this, say, July 1st, right? And we're just trying to get a feel, right? So the maturity date is going to be June 30, 2031. Okay, so it's going to happen 10 years from now. Interest-only payments, okay, that's good. The face amount, let's go out and raise $50 million. All right, so let's put that in let's get a better format for that number. 50 million, I like that. Let's say we're going to put the stated interest rate here. We only want to pay like 6%. The payment dates are going to be every 6 months at January 1st and July 1. Okay, so every 6 months, and interest-only payments. That's all, yes. All right, so we've got all the data that I think we need just to get us started. So the first thing we've got to model is we've got to determine what are the cash flow streams from this particular debt. So I'm looking at the cash outflow, right? Looking for understanding my cash outflow. So just kind of doing a little. So one of the cash flow streams that I have, is interest. And the other one is going to be principal payment. Singular, one principal payment, right? All right. So when I'm looking at these two interest payments, right? And let me put my dates here, right? So I've got an idea that's going to start on July 1st. So my first payment's going to be 1/1/2022, right? And if this is a 10-year piece of debt and I'm paying, every 6 months, then I'm going to have 20 payments. So let's drag this down to 20. I think that's 20 payments. Let's see. I think that's right. And we just need to change the formatting. We want to do, let's see. No, we don't want months there. We want to do something different. Nah, years doesn't do it either. So we're gonna have to do a little bit something different here. Let's put in 7/1/2022, 1/1/2023, and let's see if this starts getting me. I'm still not giving me what I want. Right? And so I'm ultimately going to put in all of these different payments. It might be easier just to do it this way. Payment 1. We'll just do this in number format. Payment 1, 2, 3, 4, 5. There we go. So there's my 20 payments, right? And then we know what the dates are, okay? And now I want to calculate what my interest payments are. Well, my interest payments are simply 50 million times my interest rate divided by 2. Or if the basis of this is actual over actual, then it would have to be the number of days that go by divided by 365. But we'll just make it simple. It's a 30 over 360, so we'll say times 180 divided by 360. Right? And that tells me how much what each interest payment is. And because this is fixed, they're always going to be the same. So I'm just going to drag this down and fill in all of my interest payments, right? So it's 6% annualized rate. So that means I pay $3 million for the year, but it's $1.5 million each 6 months. So we know what our interest cash outflow is going to be. My principal payment is simple. It's only going to happen one time, and it happens right here. And we'll get that in the right format. Okay. So what I've got here is I've got all of my interest payments and my principal payment. So this is my cash flows. These are my cash flow streams. So now I want to figure out, well, that is what I'm contractually obligated to pay. But how much money is someone going to give me today for this? So we can figure out what is the present value of these cash flow streams, given what the investors want for an expected return, right? And we know what they want for an expected return. They want this 7.9%, right? So I like to do it in 2 steps when I do this. I like to, just to make it a little easier. And if you've never done this before, this is probably a better way of doing it, especially in Excel. So we're going to go here and we're going to figure out what is the net present value of interest payments. All right? And then we're going to also figure out the net present value of principal payments. And both of these use a formula in Excel where we're trying to figure out where it, oops, I'm sorry about that. So equals the present value. Okay, so this returns the present value of future payments. So present value, so the rate. So what rate do we use? Well, we're trying to figure out what's the present value, not of the stated rate, but of the market rate, or what the rate is that the investor wants. So the present value is going to be 7.9%, right? And what I'm going to do is I'm going to put that, this is the, I'm going to put down here, the investor's desired rate. Okay, and we're going to put that as 7.90%. Right? So we're going to do equals the present value of this rate. Now remember, we pay every 6 months, so it's divide by 2 because it's present value of all of these payments. Well, I've got to make sure that because we're going to get the present value of all these interest payments. Well, there's 20 of them, right? Over 6%, so, or over whatever the percentages we have. So we've got to figure out what's the present value of all of these 20 payments. And since each payment is half of the annual rate, we need to divide that by half. If this was paid every quarter, then we divide this rate by 4. Then we put in a comma, and we look at the number of periods. Well, how many periods get paid? Well, it's a 10-year note, but there are 20 periods where we're making payments. Then we want to put in what's the payment. Well, the payment is our $1.5 million. So we can just choose one of those, and that'll be fine because it's the same payment every single time. The future value is going to be 0. And the type, and it tells us, is the payment happening at the beginning of the period or at the end of the period? And for us, it's happening at the end of the period. So we put in a 0 there. That's the end of the period. If payment was happening at the beginning of the period, then we'd put in a 1. And then we hit the end parentheses. So what this is going to do is it's going to give me the present value of this $1.5 million times 20 periods, the $1.5 million times that 20 period. And it's going to tell us what is the value of this, given that the investors want a return of 7.9%. And it tells us that the present value of that stream is $20 million, right? Now we want to do the exact same thing with the principal payments. I've got an extra L in here for principal, so we'll make that little edit there. And we're going to do the exact same thing. We got the equal the present value of our rate divided by 2 over still 20 periods. In this case, there's no payment, right? There's no periodic payment. But there is a future value, and that future value is that $50 million. And it's also end of the period. So this is going to give us our present value of just that singular payment in 10 years. And let's figure out what that is. So that gives us $23 million. So we get $20 million for the interest payments and $23 million for the principal. So how much money should we get in? Well, it's the cash received is going to be the sum of these two. So I'm going to issue this debt. I'm going to have to pay back $1.5 million every 6 months, and at the end of 10 years, I'm going to have to pay back $50 million. And what they're going to give me is they're going to give me $43 million in cash for that. Because I have a rate of 6%, and their desired rate is 7.9%. So what do you think would happen is if I change this desired rate, maybe their desired rate, they only want 5%. Maybe I'm a stronger company. Maybe they want only 5.25%. So let's just put that in there and see what happens to the amount of cash that I receive. 5.25%. Now let's see how much cash I get. I get more. I get 52,888,000 versus that 43 million. Huh. So if the investor, if I'm issuing debt that has a higher stated rate than what is the risk rate, remember this is the desired rate, the risk rate, then I get more cash than I'm actually issuing as far as the face amount is concerned. But if I issue this debt and the investor wants a higher return, like with the 7.9%, I'm going to get less cash. Well, what if I issued this and the investors wanted exactly 6%? How much cash do you think you'd get? And if you think through this, you should have a pretty good intuition that you should get $50 million, because the stated rate is 6%, investors want 6%, so they're going to give me the $50 million.